All right, so this is another sheet I've got for practice here. This is usually done after day 2. I don't know if there's any identicals here. A lot of good number questions on here, though. So I'm going to go through this question. I'm actually going to break it up, though. I'm going to do front of this sheet and then back of the sheet. So this is what the sheet looks like. I'm going to slide it up. So evaluate each of the following was question 1. I might have to slide it up a bit farther than that for question 6 to show. Cool. So pause it. Do it. And then unpause it. Here I go. Okay, evaluating each of the following. This is actually useful for having this document camera because I never did show you guys how to evaluate these things in your calculator. So I'll try to move it into a spot where I can see it without the lights shining on there. So in order to do P7, 2, this is just another way to write 7P2. So you could probably just do that in your head. I mean, it's going to be 7 times 6. But on your calculator, see there on my calculator, I have an NPR button. Some people have a button that's inside a stat button, so you have to actually go like into your stats. On a TI-83 calculator, you have to actually go into math here and then all the way over to probability. But on my calculator, it's just NPR. So 7 NPR brings up that P2 equals 42. Check. The answer's there. Don't need to write anything. Next one, 4P1. Okay, so I could punch this into my calculator. You should know what it is, though. It starts at 4. There's only one seat, so it's 4, as there. This one, 12P2. Again, you should be able to do that in your head. 12P2 is just 12 times 11, because it's only 2 seats starting at 12. So 132. Notice how I didn't do that one in my head. I could, though. I'm pretty sure. 11 shift P4. Now, this one's a little bit harder. 11 times 10 times 9 times 8. I'd rather not do that in my head. 7,920. Check. Okay, so those are all right. Next one. You know, actually write some stuff down here. How many ordered pairs can be formed from the set 2, 3, 4, 5, 2, 3, 4, 5, 7? So it doesn't matter that they're missing 1 or 6. All that matters is that your n here is equal to 1, 2, 3, 4, 5. So there's 5 numbers there. Now ordered pairs are just going to be 2 numbers. So it's like making a set of 2 numbers. Now it's actually not a set bracket, though. It's an ordered pair, so it's going to be more like a coordinate. So what you know about coordinates from these things is that I could have 2 and 2. That's a valid ordered pair. So this is basically telling you, because you're making ordered pairs, that repetition is allowed. And it's an ordered pair, so there are 2 seats. You've got 5 things, so it's 5 times 5. That's where they got the 25 from. How many ordered pairs can be formed from set A without repetition? Okay, so it's ordered pairs again, but no repetition, so now it's 5 and 4. So 5P4, sorry, not 5P4, my bad. 5P2 is your answer, or 20. In how many ways can a president, vice president, treasurer be chosen from 10 candidates? So n's equal to 10, k's equal to 3, 1, 2, 3 seats. If you want to do it this way, you have 10 candidates. Once you place it, though, then there's 9 and then there's 8. So repetition's not allowed. The same person can't be president and vice president unless you might live in Russia. I'm going to avoid saying his name, though, just in case this goes on YouTube and I don't want to have to worry about KGB and radioactive substances and such. Anyways, so 10, 9, 8. So this is 10P3, which is 720. 10 times 9 times 8. That goes to 72 times 10. I probably could have done that in my head. How many ordered triples can be formed from a set of 8 elements? So n's equal to 8. What we just learned about ordered triples is that we can have repetition. So there are 1, 2, 3 things. Repetition's allowed, so 8, 8, 8. So how do I write this? Simplified is I write 8 to the power of 3. So instead of just leaving it as 8 times 8 times 8, write it in power form, or exponential form. So write it in perm form is simple. If there's no repetition. With repetition, it's usually simplest to write in power form or exponent form. How many ordered pairs can be formed if there's no duplication? 8, 7, 6. So 8P3. Oh, whew. Again, this is why data is difficult and why we get things wrong in data and don't get 100%. I just read the question wrong. I'm going too fast. How many ordered pairs? Not triples this time. So it's just 8p2, it's just 8 times 7, and that's where they got the 56. Whoops. How many ordered quadruples without duplication can be formed from a set of 17 elements? How many ordered quadruples? So without duplication, so 1, 2, 3, 4, 17 elements, so 17, 16, 15, 14. Again, you don't have to draw these seats every single time. I'm just doing this because of the note. If you know that that's just going to be 17p4, do it. And 17p4. Well, again, if you don't have these fancy calculators with your 17p4 to push up there, you could just do 17 times 16 times 15 times 14, and you should get 57120. Check. How many ordered sextuplets, 6 numbers without duplication from 21? Okay, so I'm not going to bother with the seats. Hopefully you get the idea here. Starts at 21, there are 6 seats, so it counts down to 6 because there's no duplication. If there were allowed to do duplication, then it would have been just 21 to the power of 6, because it just would have been 21 times 21 times 21. Does this equal that? Hopefully. Check. How many 4-digit numerals can be formed from the set of that? 0. Well, 1, 2, 3, 4, 5, 6, 7. Oh, cool. We've got this one. So this is a good question to know how to do. Put a star beside it. So this is doing digit numbers when you have a 0 in the set. Remember that 0, 1, 2 is a 2-digit number, so you can't start with 0, which is going to make this question very interesting. How many 4-digit numbers can be formed from that set if no digit is repeated? Okay, so you can't, no repetition, 4-digit numbers, so 1, 2, 3, 4. Now, here's what we do. We take these things, so going back to the old foam numbers in a bag, your imaginary / magical bag. So you have 1, 2, 3, 4, 5, 6, 7, 8. So n's equal to 8. But on this seat, though, I can't use a 0. So it's any of the other 7. Starts with a 7. Now, once I go to this seat, though, so let's say, it doesn't matter, remember, this isn't 7 that I have to put down here, it's any one of these. So let's say that I started with a 4. See how the 0 is back in play now? So now on this seat, I have 7 again. Because here there was no 0, so there were 7 numbers. But then once I throw one of them down, let's say I threw down the 5, 0 is back in play, so it's 7 again. But then once I throw another one down, now it's 6, 5. So you end up getting 7 times 7p3. So this is a cool question with this 0 thing here. Know it. How many of these numerals are odd numbers? Okay, this is the easy one. 1, 2, 3, 4. So there's 4 numbers. Now, make it odd. So odd in the back. In order for a number to be odd, all I care about is whether it ends in an odd number. I don't care about any of the other ones. If this ends in a 3, it's odd. If it ends in a 5, it's odd. If it ends in a 2, it's even, no matter what these numbers are. Agree? You should. So, how many odd numbers can I end it with? 1, 2, 3, 4. So I can end it with 4 odd numbers. So I do that restriction first, then I go back to the beginning. Now, let's say I threw down my 3. Again, it doesn't matter. I could throw down the 1, the 3, the 5, or the 7. Let's say I threw down the 3. Now, when I go back to the beginning, though, I can't throw down the 0. So I actually have 1, 2, 3, 4, 5, 6 that I could start with. So I dropped one of them, so I have 1 less, but I also can't do the 0. Now when I go to the next thing, I've dropped two numbers down. 0's back in play, so now I'm at 6 again. And that comes to 5. So this goes to 6 times 6p3. Follow all that? Restriction there first, then you have this special 0 thing. So this is the not 0. I guess I shouldn't use that symbol because that's a null set, but anyways, this means not 0 at the start. And that's why I'm getting this 7, 7, and 6, 6 thing. Weird. Okay, anyways, how many of these numerals are even numbers? Okay, this question is difficult, and there's 2 ways to do it. I'm going to do it both ways. First of all, remember I talked before about direct and indirect? So directly, I could do 1, 2, 3, 4. And now when I go to end it in an even, it could end in 0, 2, 4, 6. But if it ends in 0, then that's going to change what happens here. So I have to actually separate this into 2 cases. So I'm going to do even but not 0. So my 2, 4, and 6. So there's 3 numbers that could be there. 2, 4, or 6. Those would make it even. Now when I go to the beginning, I have this 0 problem again. So let's say I drop the 2. I can't use a 0. So there's 6. Then I can use a 0. So there's 6. And then 5. Then down here, you have the case that is also going to end in an even if it ends in a 0. So there's only one 0. Now look how it changes the beginning though. If I drop the 0 specifically, when I go back to the beginning, I've got 7 numbers. And then 6, 5. And then I add both of these together. So I'm just going to calculate these. 6 times 6 times 5 times 3 plus 7 times 6 times 5 equals... Oh wait, no, I wanted to do them separately though, just for the sake of the note here. So this one is 540, different ways to end in 246. And then there's 7 times 6 times 5, and then there's 210. So these two add together to give you the 750. Okay, so this is the direct method, and it's hard. The indirect method is when we subtract the yes case from the total. Or we subtract the not case from the total to get the yes case, or vice versa. Anyways, in this case we've got even and odd. So I have figured out the total, which is 7765. So this is the total set, and I'm going to subtract the odd numbers. So if I do 7765, these are all the numbers, and I subtract, so those are all of them, and I subtract the odds, which was 6654, then I get the even. And hopefully these methods both give me the same number, otherwise I messed one of them up. 7 times 7 times 6 times 5. Whoops, I did 65. Let's try that again. 7 times 7 times 6 times 5 is 1,470. I was like, uh-oh, this looks wrong, but I forgot. I've got a minus here. So now I'm going to minus 6 times 6 times 5 times 4, and that's going to give me 720. And when I subtract that, ta-da! I get 750 this way as well. So, know this question. Let's put another star on this question. First of all, you need to know how to deal with this 0 when you're dealing with digit numbers. It can't start with a 0, so you usually end up getting this double counting thing. So it's got 0 and then not 0, so 0 is not in play, and then it's back in play. So you get 7, 7. Or here, 0 is not in play, then it's back in play. So even when you've got a restriction, this 0 did the same trick. Now here the 0 doesn't do the same trick, because here when we put the 0 in the end specifically, it means that now you have 7 full numbers to choose from, and then it just goes 6, 5. Because 0 doesn't bounce back in here because we had to use it there. Also, know how to do odd and even. Know either one of these methods for even. I would really suggest you learn this one. So even if they didn't ask you odd beforehand, when I usually have to do the even numbers, I will find all of them. So find all cases, find the odd cases, subtract to get your even. Go to the back.